Albert Einstein entered the world on March 14, 1879, in the small German town of Ulm. It was a quiet and unremarkable place, the kind of town where life moved slowly and nothing unusual ever seemed to happen. His mother, Pauline, was a warm and caring woman who had a deep connection to music and spent a lot of time at the piano. His father, Hermann, earned a living as a merchant, selling feathers to support the family. Albert was not an only child. He had a younger sister named Maya, and she was his one and only sibling. From the very beginning, Albert's parents noticed that their son did not behave like most children. As a baby, he was calm and unusually quiet. Instead of crying or seeking attention, he often seemed lost in thought, as if his mind was already busy trying to understand the world around him. He also began speaking later than other children his age, which caused his parents a great deal of concern. They worried that something might be wrong. Over time, however, those fears faded. As Albert grew, it became clear that he was not slow or struggling. He simply liked to think deeply and preferred solving problems on his own rather than rushing to speak. The family's home in Ulm was comfortable but modest. It was not a wealthy household filled with luxury. They did not own many possessions, yet they always had enough to live a decent life. There was stability, care, and a sense of security in their home even without riches. Music filled the house on a regular basis. Pauline often played the piano, and those melodies echoed through the rooms. Hearing that music left a lasting mark on Albert. It awakened a strong love for music that stayed with him throughout his life and later became a source of peace and inspiration. When Albert was 5 years old, his father showed him something that deeply affected him. Hermann handed him a compass, a small instrument whose needle always points north because of the Earth's magnetic field. Albert was fascinated and confused at the same time. He could not understand how the needle moved without anyone touching it. The idea that an invisible force could control something visible captured his attention completely. He thought about that compass again and again, trying to make sense of it. That moment marked the beginning of his curiosity about science and the hidden laws that shaped the universe. Later, Albert attended a Catholic school in Munich because his parents believed it offered the best education available. Despite this, he struggled with the way lessons were taught. The school focused heavily on memorization, expecting students to repeat information without truly understanding it. Albert found this approach frustrating, as he wanted to learn through reasoning and explanation. Although Albert's family was Jewish, they were not deeply religious. They rarely attended synagogue and did not strictly follow many traditions. Still, they felt proud of their Jewish background. As Albert grew older, this sense of identity turned into a strong belief in fairness. In later years, he would speak out for Jewish people and for others who were treated unjustly. During these early years, Albert absorbed many important lessons. From his family, he learned about love and support. From his mother, he gained a lifelong appreciation for music. From his father, he observed responsibility and work. From within himself, he developed a strong sense of justice. Most of all, he discovered the deep satisfaction that comes from understanding how the world works. That joy of understanding became the force that guided his life. It pushed him forward and shaped his future. In the next part of this story, an important childhood event will be explored, one that changed Albert's path and set him on the road toward becoming one of the most famous scientists the world has ever known. When Albert was 5 years old, his father, Hermann, gave him a small present that would stay with him for the rest of his life. It was not a toy and it was not a storybook. Instead, it was a compass. On the surface, a compass is just a simple object that shows direction by pointing north. But to young Albert it felt like something far greater. It was a riddle he could not solve, and that made it fascinating. Albert carefully examined the compass. Inside there was a thin needle that seemed to float freely. Nothing was touching it. There were no strings pulling it and no hands turning it. And yet the needle moved on its own. No matter how he turned the compass, the needle always found its way back to the same direction, pointing north. This amazed Albert. He stared at it again and again, trying to understand what was happening. How could something unseen control the movement of the needle? The idea made no sense to him, and that only deepened his curiosity. He asked his father for answers. He asked his teachers too. But the explanations he received did not satisfy him. They told him the compass worked because of something called magnetism. However, when Albert asked what magnetism really was or how it actually worked, no one could give him a clear answer. The adults knew the word, but they could not explain the force behind it. Instead of calming Albert's mind, this made him even more curious. Soon, Albert found himself thinking about the compass constantly. He thought about it while sitting in class, while resting at home, and even while sleeping. His thoughts kept returning to that moving needle. He began reading books about magnets and electricity, trying to find clues. He played with magnets and carried out simple experiments, watching how objects reacted to invisible forces. Albert often tried to picture those forces in his mind. He wondered what it would be like if the hidden powers behind the compass could be seen. That question stayed with him and pushed him to keep searching for answers. This experience marked the beginning of Albert's deep interest in physics. Physics is the branch of science that helps explain how the world works. It tells us why the sky has color, why the earth travels around the sun, and why a compass needle always points north. Albert wanted to understand all of it. He wanted to uncover the secrets that govern the universe. The mystery of the compass taught Albert something important. It showed him that the world is filled with wonders that are not always easy to explain. It also showed him that science gives us tools to explore those wonders. Most of all, it taught him that asking questions is not a weakness. Curiosity is how learning begins, and it is how people grow. In the next part of this story, Albert's school years will be explored. It will show how he struggled with traditional education and how he slowly discovered his own way of understanding the world around him. From a young age, Albert Einstein showed an endless curiosity about the world around him. He constantly wanted to know how things worked and why they were the way they were. Asking questions came naturally to him, and exploring new ideas excited his mind. However, once he entered school, he quickly discovered that his way of thinking did not match the system he was placed in. At that time, schools operated very differently than they do today. Teachers expected strict obedience and valued memorization above all else. Students were not encouraged to question information or think creatively. Instead, they were told to repeat facts and follow rules without discussion. Educators believed this method was the proper way to teach children. Albert strongly disagreed. Memorizing information without understanding it felt pointless to him. He found it dull and frustrating. Albert did not want to simply remember facts. He wanted to grasp the reasons behind them. Knowing what happened was not enough. He needed to understand why it happened. To him, learning should feel like an adventure filled with discovery, not a chore built on repetition. Albert's teachers struggled to understand him. They viewed his behavior as disrespectful and his constant questioning as a challenge to their authority. Some believed he was lazy or difficult. Others saw him as a disruptive student who did not follow the rules. In truth, Albert was not trying to cause problems. He was simply trying to learn in a way that made sense to him. At home, his parents grew increasingly concerned. They wanted their son to succeed in school and secure a stable future. They tried to support him as best they could, but they felt confused and helpless. They could not fully understand why Albert seemed so different from other children or why school caused him so much trouble. Despite all of this, Albert refused to give up. He continued asking questions even when it made others uncomfortable. He spent his free time reading books, experimenting, and thinking deeply about the mysteries of the universe. His curiosity never faded, no matter how much resistance he faced. These struggles at school played an important role in shaping Albert's character. They taught him how to think independently and trust his own ideas. He learned that being different was not something to fear. Standing by his beliefs, even when others disagreed, became one of his greatest strengths. These lessons helped form the foundation of the scientist he would later become. In the end, Albert Einstein never truly fit into the traditional education system. But that did not stop him from learning or growing. He carved out his own path, guided by curiosity and determination. That path eventually led him to make some of the most important scientific discoveries in history. In the next chapter, Albert's journey continues. It will show how a misunderstood and rebellious student slowly transformed into one of the most famous scientists the world has ever known. After finishing school, Albert Einstein knew he was not done learning. His curiosity was still strong, and he felt a deep need to understand how the world truly worked. Physics and mathematics held his attention more than any other subjects, so he chose to focus his studies there. To do this, he moved to Zurich, a city in Switzerland, where he enrolled at the Polytechnic Institute. The Polytechnic Institute was well known for science and technology. It attracted skilled professors who were leaders in their fields, along with talented students from across Europe. Albert felt energized by the environment. He was excited to be surrounded by people who cared about ideas, knowledge, and discovery as much as he did. He looked forward to learning new concepts and forming new connections. Living in Zurich felt very different from life in Germany. The city was larger and more active, with a faster pace and a different atmosphere. People spoke Swiss German, which was unfamiliar to Albert at first. Understanding conversations was difficult in the beginning, and this made daily life challenging. Still, he put in the effort to learn the language. Over time, it became easier and he slowly adjusted. He also made friends who helped him feel more at home in his new surroundings. His studies at the Polytechnic Institute were demanding. The coursework was intense, and the examinations required serious preparation. Albert had to push himself to keep up with the material. Even so, he welcomed the difficulty. He enjoyed being challenged, especially when it came to subjects he loved. Physics and mathematics kept his mind busy, and he found satisfaction in working through complex problems. Albert spent long hours studying. Much of his time was passed in the library, reading books, reviewing theories, and filling pages with notes. One area that especially captured his interest was theoretical physics. This branch of science focuses on ideas, models, and explanations rather than hands-on experiments. It requires imagination and deep thinking, skills that came naturally to him. Albert was able to picture abstract ideas in his mind and make sense of difficult theories. His ability to think deeply helped him understand concepts that others found confusing. During these university years, he did not only grow academically, he also developed as a person. Living away from home taught him how to take care of himself and manage his own responsibilities. He learned how to study independently and rely on his own judgment. Questioning ideas became a habit not just in the classroom but in everyday life. These skills shaped the way he thought and prepared him for the work he would do later. Despite the hard work, Albert enjoyed his time at the Polytechnic Institute. He gained knowledge, formed friendships, and strengthened his confidence as a thinker. In the year 1900, he completed his studies and earned his degree in physics. With his education finished, he stood ready to begin the next stage of his journey as a scientist. In the next stage of Albert's life, something unexpected happened. Instead of stepping into a university classroom or a research laboratory, he took a job in a place few people would connect with great scientific ideas. This position, surprising as it seemed, became one of the most important chapters of his career. It gave him the space and the mindset he needed to develop ideas that would later change the world. After graduating from the Polytechnic Institute, Albert Einstein ran into serious trouble. He wanted to work as a teacher or a researcher, but no one was offering him a position. Doors stayed closed no matter how hard he tried. This period was frustrating and stressful. He needed a steady income to survive, yet he also wanted time and energy to continue studying physics. Eventually, a solution appeared. In the year 1902, Albert accepted a job at the Swiss Patent Office in the city of Bern. A patent office is where inventors submit their ideas so they can protect them from being copied. The office reviews these inventions to decide whether they are truly original and useful. Albert was hired as a patent examiner. His role was to carefully study applications related to physics and engineering. He read detailed explanations, examined technical drawings, and worked to fully understand how each invention functioned. His task was to decide whether an idea was new and whether it had real practical value. The work required patience, focus, and strong analytical thinking. At first, Albert was disappointed. This was not the future he had imagined for himself. He dreamed of being a full-time scientist, not someone reviewing other people's inventions. Still, as time passed, he began to recognize the benefits of the job. Working at the patent office sharpened his mind. Every application forced him to break down complicated ideas and think clearly about how things worked. He had to be exact and careful, but also flexible and creative. These habits turned out to be perfect training for theoretical physics. The job also gave Albert a broad view of science and technology. He was exposed to a steady stream of new ideas and inventions. He saw how scientific principles could be turned into practical tools that help people in everyday life. This constant exposure sparked his imagination and influenced his own thinking. Even though his days were filled with office work, Albert never stopped studying physics. In the evenings and on weekends, he returned to his true passion. He read scientific papers, wrote his own ideas, and spent long hours discussing physics with close friends. That quiet time outside the office was where his most important thinking happened. During his years at the patent office, Albert produced some of his greatest work. He developed the theory of relativity and provided an explanation for the photoelectric effect. These breakthroughs transformed physics and eventually brought him worldwide recognition. In the next part of the story, the focus will turn to these discoveries. It will show how Albert's ideas were received by other scientists and how they began to change the way humanity understands the universe. This period of Albert's life marked a turning point. Step by step, he moved from being a patent examiner to becoming one of the greatest scientists in history. While he spent his days working at the patent office, his mind was never limited to paperwork alone. Beneath the surface, he was deeply involved in his own scientific research. Even while reviewing inventions for a living, Albert continued to think about the biggest questions in physics. He explored ideas about light, energy, space, and time. He built new theories in his spare moments, often late at night, driven by curiosity and determination. Eventually, he felt ready to share his thoughts with the wider scientific world. That is when he began writing scientific papers. The year 1905 became especially important. During that single year, Albert published 4 major scientific papers. Each one focused on a different problem in physics, yet all of them reflected his original way of thinking. They were based on careful logic, deep reasoning, and a fearless imagination. These papers were revolutionary, bringing entirely new ideas into a field that many believed was already complete. One of these papers explained the photoelectric effect. This effect occurs when light causes electrons to move. Albert proposed a bold explanation. He suggested that light is not only a wave but also comes in small packets of energy. He called these packets quanta. At the time, this idea sounded strange and confusing to many scientists. Still, it explained the photoelectric effect perfectly. Years later, this work earned Albert the Nobel Prize in Physics. Another groundbreaking paper introduced the special theory of relativity. This theory completely reshaped how scientists understood space and time. It showed that space and time are connected and can change depending on motion. The concepts were difficult and challenged common sense, but they explained problems that older theories could not solve. When these papers were published, they caused a strong reaction in the scientific community. Some scientists were thrilled. They immediately recognized Albert's brilliance and saw him as a rising star in physics. They wanted to learn from him and collaborate with him. Others reacted very differently. They were doubtful and uncomfortable with his ideas. To them, his theories seemed too strange and too extreme. They questioned his conclusions and demanded proof. Many were unwilling to accept such dramatic changes to established thinking. Albert did not back down. He understood that new ideas often face resistance. He knew his theories were unusual, but he also trusted his reasoning and evidence. He believed that time would prove their value. That confidence kept him moving forward, even in the face of criticism. In the next chapter, the story will follow Albert's life beyond the patent office. It will show how he became a professor and gained respect within the scientific world. It will also explore how he used his growing fame and influence to speak out for peace, fairness, and justice. The year 1905 became a defining moment in Albert Einstein's life. During that single year, he published 4 scientific papers that completely transformed the field of physics. These works were so influential that the year later became known as his Annus Mirabilis, a Latin phrase meaning miracle year. Few scientists in history had ever produced so much groundbreaking work in such a short time. Albert's first paper focused on the size of molecules and how they move. This research belonged to a branch of physics known as statistical mechanics. Using a straightforward yet powerful approach, Albert calculated the actual size of molecules. In the same paper, he explained a phenomenon called Brownian motion, which describes the random movement of tiny particles floating in a liquid. At the time, many scientists still debated whether molecules truly existed. This paper provided strong and convincing evidence that molecules were real, helping to settle a long-standing scientific argument. The second paper explored the photoelectric effect. In this work, Albert proposed that light is made up of small, discrete packets of energy. He referred to these packets as quanta, later called photons. This idea was radical because light had long been understood only as a wave. Albert showed that his explanation perfectly described how light could cause electrons to move. This paper introduced a new way of thinking about light and became a key step in the development of quantum mechanics, an entirely new field of physics. The third paper introduced the special theory of relativity. With this work, Albert challenged deeply rooted ideas about space and time. He explained that space and time are not separate entities but are linked together into a single structure known as spacetime. He also stated that the laws of physics remain the same for all observers, no matter how fast they are moving. This theory overturned traditional thinking and forced scientists to reconsider how the universe truly operates. The fourth paper expanded on the ideas of special relativity. In it, Albert introduced the now famous equation stating that energy equals mass multiplied by the speed of light squared. Written out fully, this equation shows that energy and mass are interchangeable. This discovery revealed a profound connection between matter and energy and later played a crucial role in many areas of physics, including nuclear science. Together, these four papers changed Albert's life. They made it clear to the scientific world that he was far more than a patent examiner with unusual ideas. He was a brilliant physicist with a fresh and powerful way of thinking. These works opened doors for him, allowing him to leave the patent office and begin a career in academia. They also sparked intense debate, pushing physics in new directions that would influence generations of scientists. In the next part, the focus will shift to Albert's life after his miracle year. It will explore how he handled sudden recognition and how he continued to shape the future of physics. One of the most important works Albert Einstein released during his miracle year of 1905 focused on what became known as the special theory of relativity. This theory introduced a completely new way of thinking about the basic rules that govern the physical world, and it challenged ideas that scientists had accepted for generations. Before Albert presented this theory, most scientists believed that space and time were fixed and unchanging. Time was thought to pass at the same steady pace for everyone, no matter where they were or how they moved. Space was also believed to be constant, the same in all directions and for all observers. Albert questioned these assumptions and came to a very different conclusion. In the special theory of relativity, Albert argued that space and time are not absolute. Instead, they are relative, meaning they depend on motion. According to his ideas, if a person travels at an extremely high speed, close to the speed of light, time will slow down for that person compared to someone who is standing still. At the same time, distances can shrink in the direction of motion. These ideas sounded strange and even impossible to many people, but they worked perfectly within mathematical equations. Another key part of the theory was Albert's claim that the speed of light never changes. No matter how fast an observer is moving, light always travels at the same constant speed. This idea went against common sense, but it successfully explained the results of several experiments that had confused scientists for years. When the special theory of relativity was introduced, it caused shock throughout the scientific community. It directly challenged long-standing beliefs and was difficult to understand at first. Many scientists struggled with its implications. Still, the theory was also exciting. It opened new ways of thinking and revealed possibilities that had never been considered before. The influence of special relativity was enormous. It reshaped how scientists think about space and time and led to new discoveries across physics. It also inspired technologies and research that would appear many years later. At the same time, it raised new questions about the universe, some of which scientists continue to explore even today. One of the most famous outcomes of this theory is the equation stating that energy equals mass multiplied by the speed of light squared. Written out fully, this equation shows that energy and mass are closely connected and can be transformed into one another. Before this discovery, these two ideas were seen as completely separate. This relationship between energy and mass has had powerful consequences, influencing areas such as nuclear energy and the study of black holes. It revealed a deeper structure within the universe that scientists had never fully understood before. In the next part of the story, attention will turn to the general theory of relativity. This theory expanded on Albert's earlier ideas and took them even further, allowing him to predict some of the most astonishing phenomena ever discovered in the universe. Another extraordinary paper Albert Einstein produced during his miracle year of 1905 focused on a puzzling phenomenon known as the photoelectric effect. This effect occurs when light strikes a metal surface and causes electrons to be released from that metal. Although the effect had been observed for years, no one had been able to fully explain why it happened. For a long time, scientists tried to understand this behavior using the classical theory of light. According to that traditional view, light behaves only as a wave. Based on this idea, they believed that increasing the brightness of light should provide more energy and force electrons to move, regardless of the light's color. However, experiments consistently showed results that did not match this expectation. Researchers discovered that the color of the light, not just its brightness, played a critical role. If the light did not have the correct color, electrons would not move at all, even when the light was extremely bright. This contradiction confused scientists and challenged long-standing theories. Albert approached the problem from a completely different angle. He proposed that light is not only a wave but also behaves like a particle. He suggested that light is made up of tiny packets of energy, which he called quanta, later known as photons. Each photon carries a specific amount of energy that depends on the color of the light. According to Albert's explanation, electrons can only be released if the photons striking the metal carry enough energy. If the energy of the photons is too low, no amount of additional light will cause electrons to move. This idea explained why brightness alone was not enough and why color mattered so much. At the time, this proposal was daring and controversial. It directly challenged the classical understanding of light that had been accepted for decades. Despite this, Albert's explanation matched experimental results perfectly. It solved a problem that had puzzled scientists for years. This work became a cornerstone in the development of quantum mechanics, a branch of physics that describes the behavior of very small particles such as electrons and photons. Quantum mechanics went on to become one of the most successful scientific theories ever created, explaining phenomena that older theories could not. Albert's explanation of the photoelectric effect eventually earned him the Nobel Prize in Physics in the year 1921. This award is among the highest honors a scientist can receive and recognizes the lasting impact of his ideas on the world of physics. In the next chapter, the story will move beyond the miracle year. It will explore how Albert continued to shape modern physics and how he used his growing fame and influence to speak out for peace, fairness, and justice. Albert Einstein became famous not only because of the theories he created, but also because of the unusual way he arrived at them. He did not rely only on laboratory experiments or complex equipment. One of his most powerful tools was something far simpler, yet incredibly effective. He used what is known as a thought experiment. A thought experiment is a method of exploring an idea entirely in the mind. Instead of testing something with physical objects, a scientist imagines a situation and carefully thinks through what should happen according to known laws. Albert used this approach constantly. He pictured different scenarios, questioned basic assumptions, and tried to predict outcomes using logic and reasoning. Looking at problems from fresh angles was a central part of how he worked. One of his most famous thought experiments involved a falling elevator. This mental exercise played a critical role in the creation of the general theory of relativity. Albert imagined a person standing inside an elevator that was falling freely under the influence of gravity. In that situation, the person would not feel their own weight. They would experience the same sensation as someone floating in outer space, far away from any gravitational pull. This simple but powerful idea led Albert to a bold conclusion. He realized that gravity might not be a traditional force at all. Instead, he proposed that gravity is the result of space and time being curved by mass and energy. Objects move the way they do because they follow the shape of this curved spacetime. This insight became the foundation of the general theory of relativity. The theory built upon his earlier work, known as the special theory of relativity. While the special theory described motion in situations without gravity, the general theory expanded those ideas to include gravity itself. This made the new theory far more comprehensive and applicable to the real universe. The general theory of relativity was one of the greatest achievements in the history of physics. It completely changed how scientists understood gravity, one of the most fundamental aspects of nature. The theory also predicted extraordinary phenomena, including black holes and gravitational waves. It reshaped ideas about the universe and helped lead to modern concepts such as the Big Bang. Albert's thought experiments were not idle daydreams or clever tricks. They were a serious and disciplined way of investigating reality. Through imagination guided by logic, he explored new possibilities, tested ideas, and made predictions that could later be confirmed. His work demonstrated how powerful human creativity can be when combined with careful reasoning. In the next part, The focus will move deeper into the general theory of relativity and its influence on science and society. It will show how Albert's ideas were tested, confirmed, and how they continue to inspire scientists and thinkers around the world today. One of the most thrilling moments in Albert Einstein's career arrived in the year 1919, when his general theory of relativity faced a true test in the real world. Until then, his ideas were supported mainly by mathematics and careful reasoning. Now, there was a chance to see whether nature itself would agree with his predictions, especially his claims about how light behaves near massive objects. According to the general theory of relativity, gravity is not a force in the usual sense. Instead, it is caused by the bending or curvature of space and time created by mass and energy. Because of this curvature, Albert argued that light should not always travel in a straight line. When light passes close to something very massive such as the sun, its path should curve. This bending of light later became known as gravitational lensing. Albert believed there was a way to observe this effect. He predicted that during a solar eclipse, when the moon blocks the bright light of the sun, stars near the sun would become visible. The light from those stars would pass close to the sun on its journey to Earth. If his theory was correct, the sun's gravity would bend that light slightly, making the stars appear to be in a different position than usual. In 1919, a British astronomer named Arthur Eddington organized a scientific expedition to test this idea. He traveled to the island of Principe, located off the west coast of Africa, where the solar eclipse could be clearly seen. During the eclipse, Eddington took photographs of the stars near the sun and later compared their positions to where those stars normally appeared in the sky. When Eddington carefully studied the photographs, the results were clear. The stars were slightly shifted from their expected positions, exactly as Albert had predicted. The change was small, but it was measurable and undeniable. This observation provided powerful evidence in support of the general theory of relativity. The confirmation was dramatic. It marked a major victory for Albert and a historic moment for physics. For the first time, his theory had been proven through direct observation. News of the discovery spread quickly across the globe, and Albert suddenly became famous far beyond scientific circles. Newspapers around the world praised him as a genius and compared him to Isaac Newton. People were fascinated by his ideas, even though many found them difficult to understand. They were especially intrigued by the thought that a single equation, stating that energy equals mass multiplied by the speed of light squared, could help explain how the universe works. In the next part of the story, the focus will shift to Albert's life after this extraordinary moment. It will explore how he handled sudden fame, how he continued contributing to science and society, and what his personal beliefs and values revealed about the man behind the theories. The general theory of relativity stands as one of Albert Einstein's greatest achievements. It completely transformed how scientists understand the universe and left a lasting mark on physics and astronomy. Its influence reaches far beyond one single idea, reshaping entire fields of study. Before this theory was introduced, scientists relied mainly on Isaac Newton's laws of motion and gravity to explain how the universe works. These laws are extremely effective in everyday situations and remain useful even today. However, they begin to fail when objects become extremely massive or move at incredibly high speeds. In those extreme conditions, Newton's framework is no longer enough. The general theory of relativity filled this gap by offering a deeper and more accurate description of reality. One of the most striking predictions of the general theory of relativity was the existence of black holes. A black hole is a region of spacetime where gravity becomes so powerful that nothing can escape, not even light itself. These objects were first predicted through Albert's equations long before there was any direct evidence for them. Since then, astronomers have observed black holes many times, confirming one of the theory's most astonishing predictions. Today, black holes remain among the most mysterious and fascinating objects in the universe. Another major outcome of the theory was the prediction of gravitational waves. These waves are ripples in space-time created when massive objects accelerate, such as when two large stars collide. Albert predicted their existence, but they were not detected until the year 2015, exactly 100 years later. Their discovery marked a historic moment in science and opened an entirely new way for astronomers to study the universe. The general theory of relativity also changed how scientists think about the universe as a whole. It played a key role in the development of the Big Bang theory, which states that the universe began in an extremely hot and dense state about 13.8 billion years ago. Over time, this idea has been supported by many observations and has become the standard model used in modern cosmology. Beyond its scientific importance, the general theory of relativity has also had a powerful cultural impact. It reshaped how people think about space and time, matter and energy, and even reality itself. The theory has inspired artists, writers, philosophers, and thinkers from many different fields. Over time, it became more than a scientific achievement. It became a symbol of human curiosity and imagination, showing what is possible when creative thinking is combined with careful reasoning. It stands as a reminder of humanity's ability to explore the deepest mysteries of the universe. In the next chapter, the story will turn to Albert's life after the confirmation of his general theory of relativity. It will explore how he handled his growing fame, how he continued his scientific work, and how he became an outspoken supporter of peace and human rights. During the 1930s, the world entered a period of deep turmoil, and Albert Einstein's life was strongly affected by these changes. In Germany, the Nazi Party rose to power and spread aggressive anti-Semitic policies. As a Jewish man, Albert understood that remaining in Germany was no longer safe. The situation grew more dangerous by the day, and he made the difficult decision to leave his homeland permanently. Around this time, Albert received an invitation to join the newly established Institute for Advanced Study in Princeton, New Jersey, in the United States. This institute was unlike most academic institutions. It was created as a quiet place where scholars could focus entirely on research, free from teaching obligations and administrative responsibilities. For Albert, this environment was ideal. It offered him the freedom and calm he needed to continue thinking deeply about science. In the year 1933, Albert and his wife, Elsa, moved to Princeton. They purchased a house at 112 Mercer Street, which would remain their home for the rest of their lives. Albert adapted quickly to his new surroundings. He appreciated Princeton's peaceful, small-town atmosphere and found comfort in its slower pace. He developed simple routines that brought him joy. He often took long walks through town, played the violin to relax his mind, and spent time sailing on a nearby lake. These quiet activities gave him balance and peace. Albert also valued the intellectual community around him and enjoyed conversations with fellow scholars at the Institute. At the Institute for Advanced Study, Albert remained deeply engaged in scientific work. He continued exploring the general theory of relativity, examining its consequences and working to improve its predictions. At the same time, he devoted much effort to a challenging idea known as a unified field theory. His goal was to create a single theoretical framework that could explain all the fundamental forces of nature. This task proved to be extremely difficult, and Albert was never able to complete it. Even so, his attempts were far from wasted. His ideas inspired discussion, debate, and further research among scientists around the world, pushing the field forward. Beyond science, Albert became increasingly active in public life. He spoke openly about important social and political issues, including nuclear disarmament, civil rights, and the importance of education. Using his worldwide fame, he drew attention to these causes and urged people to work toward peace and fairness. Over time, Albert became a trusted and respected public figure. Many people listened to him not only because of his scientific brilliance, but also because of his strong moral character and honesty. In the next part, the story will explore Albert's role during the Second World War, his thoughts on the atomic bomb, and his involvement in the civil rights movement. It will show how he combined scientific insight with deep moral conviction to influence the world beyond physics. In the later stage of his life, Albert Einstein devoted himself to a single demanding goal that would occupy him until the very end of his scientific career. He set out to discover what he called a unified field theory, an idea meant to bring all the fundamental forces of nature together into one complete and elegant explanation. At the time, Albert was focused on combining two known forces. The first was gravity, which he had already described through his general theory of relativity. The second was electromagnetism, which was explained by the equations developed by James Clerk Maxwell. These were the only fundamental forces known then. The strong nuclear force and the weak nuclear force would not be discovered until many years later. Albert believed that nature was deeply connected at its core. He was convinced that a single mathematical framework could explain both gravity and electromagnetism. Finding such a set of equations, he thought, would reveal a deeper order in the universe and show that seemingly separate forces were actually part of one unified system. This goal was extremely ambitious and filled with obstacles. Gravity and electromagnetism were described using very different mathematical languages. They dealt with different types of phenomena and operated on very different scales. Bringing them together into one theory proved to be an enormous challenge. Despite years of effort, Albert was unable to complete a successful unified field theory. The models he proposed did not match experimental evidence, and most physicists did not accept his approach. Meanwhile, the scientific community was moving in another direction. Quantum mechanics was gaining attention and success, offering strong explanations for the behavior of atoms and subatomic particles, areas where classical theory struggled. Even though Albert did not reach his goal, his work was far from meaningless. His search encouraged new ways of thinking and sparked valuable discussion among scientists. It pushed theoretical physics forward and opened new paths for exploration. Many researchers were inspired by his belief in the unity and beauty of nature. Through this unfinished quest, Albert demonstrated the importance of courage in science. He showed that pursuing bold ideas, even when success is uncertain, has great value. His work reminded the world that science is not about reaching a final answer, but about continually seeking deeper truth. In the next part, the focus will turn to Albert's final years, his lasting legacy, and the impact he has had on the world. It will show how his ideas continue to inspire scientists and thinkers, and how his spirit lives on through humanity's ongoing search for knowledge and understanding. Although Albert Einstein is best known for his revolutionary work in science, his influence reached far beyond laboratories and equations. In the later years of his life, he became a strong and outspoken supporter of peace, human rights, and social justice. Using his worldwide reputation, he drew attention to issues that mattered deeply to him and spoke with honesty and conviction. Albert believed strongly in pacifism. The enormous destruction and human suffering he witnessed during the First World War left a lasting mark on him. From that point on, he felt convinced that war could never truly solve conflicts between nations. He openly criticized militarism and became involved in several peace organizations. He often emphasized that lasting peace could not be achieved through violence, but only through mutual understanding between people. The outbreak of the Second World War placed Albert in a painful moral dilemma. He knew that the Nazi government in Germany was attempting to develop powerful new weapons based on atomic energy. The possibility that such weapons could fall into the hands of that regime deeply alarmed him. In the year 1939, he signed a letter addressed to President Franklin Roosevelt of the United States. In this letter, he warned about the danger and urged the government to support research into atomic energy. This message helped bring attention to the issue and contributed to the creation of the Manhattan Project, which ultimately led to the development of the atomic bomb. After the war ended and the devastating power of nuclear weapons became clear to the world, Albert felt deep regret over his involvement. He believed that such weapons posed a grave threat to humanity. From that point forward, he became one of the strongest voices calling for nuclear disarmament. He argued passionately for international cooperation and for the peaceful use of atomic energy. Working alongside other scientists, he warned the public about the dangers of nuclear weapons and urged world leaders to act responsibly. Albert also took a firm stand on civil rights. While living in the United States, he was deeply troubled by the racism he observed. He spoke out against discrimination and used his influence to support equality. He formed friendships with prominent black leaders and activists, including Paul Robeson and William Edward Burghardt Du Bois, and openly supported their efforts. In addition, Albert expressed support for the newly established State of Israel. He viewed it as a safe haven for Jewish people who had endured persecution and violence in Europe. His support was rooted in a desire for dignity, safety, and justice rather than political power. During his final years, Albert continued working on scientific problems, but he dedicated increasing time to social and political causes. He passed away in the year 1955, leaving behind a powerful legacy. That legacy includes groundbreaking scientific discoveries, courageous activism, and a deep commitment to human values. In the next chapter, the focus will turn to reflecting on Albert's life as a whole. It will examine how his ideas continue to shape the modern world, his lasting contributions to science and society, and why he remains a symbol of human curiosity, creativity, and moral responsibility. Albert Einstein was far more than a gifted scientist. Over time, he became a cultural symbol, representing brilliance, imagination, and originality. Long after his passing, his influence has remained strong. His familiar appearance, marked by unruly hair and thoughtful, expressive eyes, is instantly recognizable and has been recreated countless times in popular culture around the world. Albert's rise to worldwide fame began with his revolutionary scientific work, especially the general theory of relativity. When this theory was confirmed in the year 1919 during the solar eclipse experiment, newspapers across the globe reported the news. Almost overnight, Albert was pushed into the public spotlight. He was celebrated as a scientific hero, someone whose ideas had opened new doors to understanding the universe. However, his fame was never based solely on science. People were also drawn to who he was as a person. Albert was admired for his humility, his sharp sense of humor, and his refusal to conform to social expectations. He lived simply and thought independently. He was known as a pacifist, a humanitarian, and a strong supporter of civil rights. To many, he represented the ideal of a free thinker, someone who questioned authority and followed his own moral compass. These personal qualities helped Albert connect with people far beyond the scientific community. His image appeared in advertisements, cartoons, and films. His words were widely shared and remembered. His life story was told again and again through books, documentaries, and biographies. Over time, he came to symbolize the scientist as a creative explorer, a seeker of truth, and someone who used knowledge in service of humanity. Even today, Albert's presence in popular culture remains powerful. He is frequently mentioned in movies, television shows, music, and literature. His theories inspire science fiction and speculative stories. His face appears in art, graphic design, and fashion. His ideas are taught in classrooms and debated in universities across the world. Albert's lasting popularity reflects more than intellectual achievement. It shows that people admire both his remarkable mind and his strong human values. He is remembered not only as a genius, but also as someone who cared deeply about the world and the people in it. For many, he represents an ideal balance between scientific brilliance and moral responsibility. In the next part, attention will turn to Albert's legacy within science itself. It will explore how his theories reshaped humanity's understanding of the universe and how his spirit of curiosity continues to inspire scientists and researchers today. Albert Einstein's contributions to science have left an enduring mark on human knowledge. His ideas transformed physics and continue to guide modern research. His most well-known achievement is the theory of relativity, which includes both the special theory of relativity and the general theory of relativity. The special theory of relativity, published in the year 1905, introduced the groundbreaking idea that space and time are not separate, but form a single connected structure known as spacetime. It also introduced the famous equation stating that energy equals mass multiplied by the speed of light squared. Written out fully, this equation showed that an enormous amount of energy can be released from even a tiny amount of matter. This insight later became one of the key ideas behind the development of nuclear energy, demonstrating just how powerful matter truly is. The general theory of relativity, published in the year 1915, went even further. In this theory, Albert described gravity not as a simple force, but as a bending of space-time created by mass and energy. This new view replaced Isaac Newton's law of universal gravitation in extreme conditions. It successfully predicted the bending of light near massive objects, the slow shift in the orbit of the planet Mercury, and the existence of black holes and gravitational waves. Over time, every one of these predictions has been confirmed through careful observation and experimentation. Beyond relativity, Albert also made major contributions to quantum mechanics. He introduced the idea that light can behave like a particle, known as a photon. Using this concept, he explained the photoelectric effect, which occurs when light causes electrons to be released from a material. This work earned him the Nobel Prize in Physics in the year 1921. Albert's influence on science extended far beyond his own discoveries. He played an important role in shaping quantum mechanics by questioning its foundations and challenging other scientists to think more deeply. These debates helped push the field forward and led to a richer understanding of the theory. Through his originality, curiosity, and determination, he inspired generations of scientists to explore new ideas and ask difficult questions. Albert's scientific legacy is vast. His theories expanded human understanding of the universe, from the smallest particles to the largest structures in space. His work helped drive technological progress and influenced many branches of science, including cosmology, particle physics, and nuclear physics. In the final part of this chapter, it is worth reflecting on the lessons Albert's life and work offer. His willingness to question accepted ideas, his courage to follow evidence wherever it led, and his dedication to peace and justice remain deeply inspiring. Albert Einstein was not only a brilliant scientist, but also a committed humanitarian. His beliefs reached far beyond laboratories and lecture halls. He held a deep respect for human life and believed strongly in cooperation over conflict. His humanitarian outlook was shaped by what he witnessed in the world around him. The destruction caused by the First and Second World Wars, along with the rise of nuclear weapons, left a profound impression on him. Albert spoke openly against the violence of war and warned about the dangers of unchecked military power. He supported global disarmament and feared the consequences of nuclear conflict. One of his most well-known statements reflected this concern, when he said that while he did not know what weapons would be used in a Third World War, a fourth would be fought with sticks and stones. This remark revealed his belief that nuclear war could threaten the future of civilization itself. Believing deeply in the shared dignity of all people, Albert consistently argued that humanity's survival depended on understanding, cooperation, and mutual respect. His life stands as a reminder that great knowledge carries great responsibility, and that the pursuit of truth is most meaningful when it is guided by compassion. Above all else, Albert believed deeply in the equal worth of every human being. He was a strong supporter of civil rights and racial equality, especially during his years in the United States. He spoke openly against racism and segregation at a time when doing so was not always popular or safe. Albert supported the civil rights movement and used his public voice to condemn injustice. His letters and friendships with influential figures such as William Edward Burghardt Du Bois and Paul Robeson clearly reflected his commitment to racial justice and human dignity. Albert also placed great importance on education and the search for truth. To him, science was more than a way to explain the universe. It was a powerful tool for developing critical thinking, curiosity, and independent thought. He encouraged young people to question accepted ideas, to think for themselves, and to hold on to their sense of wonder. He believed that real learning comes from curiosity, not from blind acceptance. In international affairs, Albert supported the idea of a shared global community. He believed that humanity's biggest challenges could not be solved by individual nations acting alone. He supported the United Nations and saw international cooperation as essential for addressing issues such as war, poverty, and disease. He imagined a world in which countries worked together for the common good, while respecting human rights and individual freedoms. Albert Einstein's humanitarian legacy is just as powerful as his scientific one. His compassion, moral courage, and dedication to peace and justice continue to inspire people across the globe. His life shows that science and human values do not need to be separate. Instead, they can strengthen one another when guided by empathy and responsibility. As this story comes to an end, we look back on the extraordinary journey of Albert Einstein. He began as a curious child and grew into a revolutionary scientist, a global icon, and a committed humanitarian. His life stands as proof of the power of curiosity, the beauty of scientific discovery, and the potential within every person to make a meaningful difference in the world.